This is the first session of statistics for AI and data science. In this session, we will learn some basic concepts of probability and statistics that are extremely useful in machine learning. Also, you should know that probability and statistics are fundamental areas in mathematics. Let me write it here. These are the fundamental areas in mathematics. Mathematics, which are extremely important, or you can say which are super important in machine learning, which are super important in machine learning. Fine. Before we go and understand an important idea in probability, let me tell you why probability and statistics are important. Let me open a pair plot here, which I have discussed in exploratory data analysis. If some of you want to have basic understanding of exploratory data analysis, you can watch my playlist, Exploratory Data Analysis, whose link I will put in the description section of the video. This is a plot between two variables. I'm using pair plot here to explain you an idea why probability and statistics are important. For example, let's take this case. So this is one of the pair plots. It's a scatter plot between petal width on the y-axis and petal length on the x-axis. This is from our IRIS dataset that we saw in exploratory data analysis. There is a nice legend here. So here blue dot here is setosa, orange dot is versicolor, and this green dot is virginica. You can see this from here. Let me zoom this so that it is easy for you to see. So you can see this pair plot between petal length on the x-axis and petal width on the y-axis. This green dot is my virginica, this blue dot is my versicolor, and this is my setosa. This blue dot is my setosa. You can see this pair plot here. Here petal length is on the x-axis and petal width is on the y-axis. Now let's assume that I have a data point. So let's say I have a data point here at this point. I'm taking this point. So I have a data point at this point. Fine. Suppose I get a new flower. So this thick point is a new flower that I got. Let me circle it so that it is easy for you to understand. So this thick point is a new flower that I got. Let's say I picked up a new flower from the garden, from the iris family, and I found that its petal length is this much. So this is my petal length. It is approximately 5. And let's say my petal width is between 1.5 to 2.0. So it will be somewhere around 1.75. So my petal length is equal to 5, and my petal width, let's say, is equal to 1.75. This is just an approximation. Now the question here is, if you notice in this scatter plot, your setosas are very well separated from versicolors and virginicas. This is the reason where you have versicolors, and this is the reason where you typically notice your virginicas. Now given a point here, which is the intersection of these two regions, this is your versicolor region and this is your virginica regions, right? So let's call this new flower that we picked up as XQ. So I'm calling this as, let's say, XQ. Fine. Where subscript Q stands for query point. This query point XQ has a petal length of 5 and a petal width of 1.75. I know for sure it's not setosa, but the question is it versicolor or virginica? To answer this simple question, I cannot exactly say whether it's versicolor or virginica. So instead of saying whether it's virginica or versicolor, What if I can say, I think that this new flower, your query flower XQ, belongs to versicolor with a probability of 0.8. Let's say if I will write it here, it belongs to versicolor with a probability of 0.8. And it belongs to Virginica with a probability of, let's say, 0.2. Fine. So what does it means? I could say that instead of either declaring your XQ as either versicolor or Virginica, I could say that there is a 80% chance that it belongs to versicolor, and there is a 20% chance that it belongs to Virginica, and there is a 0% chance that it belongs to Setosa. Fine. Point 8 here implies 80%. Let me write it here. And 0.2 here implies 20%. And 0% here implies nothing. Here our task is classification, but we are not able to exactly classify a data point into versicolor or Virginica. So instead of being very decisive in calling it Virginica or versicolor, what if I give a probabilistic, let me write it, probabilistic or chance-based score. Chance-based score. So I think that there is a 80% chance it is versicolor, and there is a 20% chance that it's Virginica, correct? This is where probability sips in. To put it very simply, this is how probability is used in machine learning. Hey everyone, just wanted to take a quick pause to mention that if you are diving deep into statistics for data science, like we are doing today, you might find it helpful to have some additional resources by your side, whether it's a book to brush up on the basics or a new computer setup to crunch those numbers faster. I have curated a list of recommended products just for you. Check out the description section below for links to these fantastic tools and resources. They are handpicked to aid your learning journey. Happy exploring. Let's transition back to our discussion. In the exploratory data analysis playlist, we have learned some concepts such as histogram, PDF, probability density function, CDF, cumulative distribution function, CDF, mean, variance, standard deviation, etc., etc. Fine. All these are actually concepts in probability and statistics. Even though we use them in exploratory data analysis, these are all very, very fundamental concepts. We will learn all these concepts in more details in probability and statistics. Now, having understood why probability and statistics are important areas to study, and since we have motivated ourselves from the very simple example of classification of iris flowers that we just saw, let's understand some notations. The first important idea is called an idea of random variable. Let me write it, RANDOM, random variable. So we know that what variables are in programming. Fine. To understand what variables in a programming is, let's take an integer variable x is equal to 2. Here x is a variable which could take any integer value. Then I can change it from x is equal to 2 to x is equal to, let's say, 3. It's a similar idea, except that a random variable basically can take multiple values. Instead of defining it in a very abstract sense, let me define it with an example. Let's assume I have a dice. A dice has 6 sides. We know a dice has 6 sides. 1, 2, 3, 4, 5, and 6. Let's assume I roll a fair dice. Roll a fair dice. When I roll a fair dice, I can get any one of these outcomes, that is 1, 2, 3, 4, 5, and 6, 5. And all of these outcomes are equally likely to arrive at. So let me write it here, equally likely. Equally likely. The term equally likely in terms of probability refers to a situation where each outcome of an experiment has the same chance or probability of occurring. It has the same chance or probability of occurring. Probability of occurring. So I could define a random variable, let's say as x, which is the outcome of an experiment. The experiment here is nothing but rolling a dice. And rolling a dice is an experiment which can have a random outcome. It can have any one of the 6 outcomes. Fine. So here x can take a value of 1. It can take a value of 2, 3, 4, 5, 6. So here x, typically random variables are represented with a capital X. Fine. So having understood this, let's take an example of tossing a coin. So here tossing a coin is let's take an example of tossing a coin. Tossing of a coin is a random experiment. Let's call that random variable as, let's say, y. So what all values it can take? It can take head or it can take tail. Fine. And both of them are equally likely. So here y is also a random variable which can take one of the outcomes of this random experiment, which is nothing but tossing a coin. And since we have understood what a random variable means, let's also understand some more notations here. Let's understand probability. Probability provides a measure of how likely it is for a specific event, to occur. It is often represented as a fraction, decimal, or percentage. It quantifies the uncertainty of an outcome. So probability basically quantifies the uncertainty of an outcome. Fine. Probability always have a numerical values between 0 and 1. 0 and 1, where 0 indicates impossibility and 1 indicates certainty. Here 1 indicates certainty, and 0 indicates impossibility. Probability is calculated using the formula. Let's say probability is equal to probability P is equal to number of favorable outcomes by total number of possible outcomes. Total number of possible outcomes. Fine. So number of what it means to be a number of favorable outcomes? the number of outcomes that satisfy the condition of interest. And the total number of possible outcomes is the total number of all the outcomes in the sample space. So let's stick with our rolling a dice example or experiment. Let's assume X is a random variable which can take a value 1, 2, 3, 4, 5, and 6. This is my dice roll example. Dice roll example. Here X is a random variable which can take one of the outcomes of my random phenomena, which is rolling a dice. So what is the probability that X is equal to 1? Let me write it. What is the probability that X is equal to 1? Since all these events are equally probable, there are 6 events and all of them are equally probable. So the probability that X is equal to 1 is 1 by 6. 1 by 6. Similarly, the probability of X is equal to, let's say, 2 is 1 by 6, right? Now, what is the probability that X is an even number? So, how many even numbers are there? Even numbers are 2, 4, and 6. So, of these 6 outcomes, where each of them are equally likely, 3 outcomes are even, which means the probability that X is even is typically 3 by 6, which is equal to 1 by 2, right? Since I have 3 events here, I can also write this as probability of X is equal to 2 plus probability of X is equal to 4 plus probability of X is equal to 6. Fine. So here I will get 1 by 6 plus 1 by 6 plus 1 by 6 is equal to 1 by 2. Remember, when I get my random variable having a value of 2, it means it's exactly 2. It's not 4 or something else. So which is nothing but 1 by 6 plus 1 by 6 plus 1 by 6, which is nothing but your 1 by 2. By summing all this, similarly, the probability that X is odd is also 1 by 2, right? Probability that X is equal to odd is also 1 by 2. It also works on the same principle because we have 3 odd numbers here, 1, 3, and 5. So this is a simple notation. So whenever you see something like this, you should read it as probability of a random variable X taking a value of 1. And this simple notation can sometimes get very hard. For example, I could write probability of X equals to X is equal to X1. So what is this? Let's learn how to read this. It means that the probability that a random variable X takes a value of X1, sometimes this is written in shorthand as just as a notation. We are just learning notations here. No major leaps of understanding, no major grand concept. This is a simple notation. So instead of writing this whole term here, if I know that a random variable is X, sometimes people also write it as probability of X1. Fine. This is much more concise and more compact way of writing the same thing. So this is a simple notation of writing probability of a random variable taking a value. So we have discussed notations till now. Now let's understand 2 types of random variables. First, take the example of dice rolling. So dice rolling. So let's assume X is your dice rolling. And X is the outcome of rolling a dice. So I know 1, 2, 3, 4, 5, and 6. These are the outcomes of a rolling a dice. It means it can take any one of the 6 values. Now let's take another experiment. This experiment is height of a randomly picked student in a class. So let me write it here. Height of a randomly picked student in a class. Student in a class. Fine. It means I pick a student in a class and I measure the height of a student. Let me call that random variable as y. Fine. Let's assume, just for simplicity, that the height of most students lie between, let's say, 120 centimeter and 190 centimeter. So most students can take values between 120 and 190 centimeter. Of course, there might be some people who are shorter than 120 centimeter and who are taller than 190 centimeter, but most people lie in this region. So your y, which is nothing but height of a randomly picked student in a class, could be something like this. Y could be, let's say, 159.45, or y could also be 142. Let's say 62. It could be any real number here. Fine. Now a random variable which has a set of outcomes. So here my outcome. So my x can take any one of the 6 values here. In case of dice rolling, here x can take any one of the 6 values. It can't take 7 or it can't take 4.5. Here x can't take 7 and it can't take 4.5. It can only take values from this 1, 2, 3, 4, 5, and 6. Fine. So if a random variable can take one value in a finite set of values, it's called a discrete random variable, because it can take only one of the values from a discrete set. While a random variable like y here, which can take any real value here, is called a continuous random variable. So this y can take any value from 120 to 190 centimeter. It may take values below this and above this also. So this is an example of discrete random variable, and this is an example of continuous random variable. So you must have understood this. Again, I am just defining terms here. I'm not explaining some grand concept. As I just told you a while ago, we are just learning what a bunch of terms mean. So a discrete random variable is a random variable which can take values from a set of values, while a continuous random variable is basically a random variable which can take any real value in this case. Fine. So this is also a very simple idea of what a continuous and discrete random variable is. Let's understand a related concept called an outlier. I just wanted to quickly go over this idea because we will keep revisiting this idea. Suppose I have y, which is a height of a randomly picked student in a class. We have just discussed this, right? So let's assume I collected lot of observations for my random variable y. Let's assume I picked a student and the height of the student is, let's say, 122.2 centimeter. Then I picked one more student whose height is, let's say, 146.4 centimeter. Let's assume I picked one more student who is 132.5 centimeter, and so on and so forth. So when I picked a lot of observations like this, let's assume I pick an observation which is, let's say I am picking one observation which is 12.26. And then I got again another observation which is, let's say, 156.23, etc., etc. Now you will notice that all of my numbers here are within a sensible range of what a height of a student here, except this number 12.26, right? Such an observation is called an outlier observation, and outliers can happen because of multiple reasons. So in this case, the outlier could have happened because somebody, instead of writing 122.6, have mistakenly written it as 12.26. So it could be human errors, it could be observational errors, it could be that there is actually one person. So for example, if we have one more value here in our this set of values, and let's say I am writing this value as 92.6, let's write 92.6, fine. So this is one more observation I have added here in my set of observations. You could call this also as an outlier, but it could just be a person who is very short, who has some genetic abnormality, and hence that person is very short, and he or she happens to be in our class, right? This is also an outlier. So outlier could be present in your observation because of various reasons. It could be human error, it could be a genuine outlier, right? As in this case 92.6 value. But outliers can corrupt your observation. What outliers can do? Outliers can corrupt observations. Fine. For example, mean can easily be corrupted because of a single or a small set of outliers, right? Similarly, your variance also get impacted by outliers, and hence we learned a concept called median. Similarly, we learned concepts like MAD, median, absolute deviation, to avoid the problems of outliers. We will look at these things in great details in the coming session. If you are really enjoying the content, don't forget to like, subscribe, and put all your doubts in the comment section of the video. I am happy to respond to all your queries. Thanks. Keep learning, keep smiling.